This is the final video in this series for the acid-base titration prac. So here's our original values, and we're going to look at the calculations that Bob has done for you just for solution 1 using bromophenyl blue. So here's the original values, 8.2, 8.1, 8.2 with a blank of 0.1. So Bob, what have you done for us here?
So what I've done here is now I've actually included the corrected values. Now remember from our very first title that we did, we actually got a high value. That's because we're still determining what our values, our readings are going to be. So I've actually excluded that result because it'll actually interfere with our final results. So what I'm going to do is continue using the second, third and fourth titer number. Okay, so what I've done is I've need to determine the mean value. So sorry, before I go that, I've actually done the corrected value, and the corrected value is actually our initial titer, which in this case 8.2. Subtract that from our blank, which is 0.1 of a mil. So what happens is 8.2 now it becomes 8.1. 8.1 our initial value now becomes 8. And our final value, which was 8.2 minus the blank, is 8.1. So these are now corrected values. What I've now done is I prepared the mean, and the mean essentially is all these numbers added together divided by the total number. In this case, it will be 8.1 plus 8.0 plus 8.1. All of those added together and then divided by 3, and that will give us a mean value of 8.06. Now the next thing that's required to do is to determine the standard deviation. Now here I've got a worked example of determining the standard deviation.
All right, and students, well, those students that have done weekly prac classes will already have some experience using this formula from the first prac to work out standard deviation.
So let's use the values for calcium hydroxide solution number 1, which is 8.1, 8.0 and 8.1, and the mean of those numbers is 8.06. So let's use a worked example. So we start with standard deviation. The formula for standard deviation is volume 1 minus the mean, all squared, plus volume 2 minus the mean, that number also is squared, plus volume 3 minus the mean squared. Now we're only using 3 values for this standard deviation for calcium hydroxide in solution number 1. For the other subsequent reactions or titrations, you'll actually need to include all 4 values. Okay, so let's use, say, calcium hydroxide solution number 2. You'd include 8.7, 8.5, 8.3 and 8.5, and the mean of those values is 8.5. So let's go back to here. So all those 3 numbers that have been squared are then divided by n, which is the number of samples minus 1, and then you get the square root of that total or the final value. So let's use bromophenyl blue in calcium hydroxide solution number 1. We got 8.1, which is over here, there, minus 8.06, which is our mean, all squared, plus 8.0 minus 8.06, which again is our mean, all squared, plus 8.1 minus 8.06, again all squared. And then divided by 3, because we're only using 3 values, minus 1, which in this case will be 2. So let's go to the next step in this equation. So it's 0.016 plus 0.0036 plus 0.0016, all divided by 2, then squared. So it works out to 0.0068 divided by 2. Then once again, it has to be always squared. And the final answer will be 0.0034 squared, which is actually, or square rooted, sorry, which is 0.0583 the value. And what we do is then we go to 2 significant figures, so it's just going to be 0.05.
Okay. Next step.
And then the final part, in order to complete this final table, is to actually determine the overall percentage of calcium hydroxide. So the way we determine that is actually using this formula, which is on page 48 of your prac manual, which is A minus B. Now A is the initial titer, minus B, which is your blank, in litres. Now it's important to actually convert your millilitres into litres. Then you times that by 74, which is the molecular weight of calcium hydroxide, times 100%, because what we're doing is actually looking for as an overall percentage of calcium hydroxide, times the concentration of the hydrochloric acid, which was our titrant, which is what we use to titrate against the calcium hydroxide. And then we have to times by 50. And the reason we times it by 50 is because we've only used a 20 ml aliquot from a 1 litre solution. So we actually did, remember initially we did 1 gram dissolved in 1 litre, which is a 0.1% solution. We need to scale up because we've only titrated against 20 mils. And there's 50, 20 mil aliquots in 1 litre.
So that's the dilution factor.
Yes.
Okay.
And then we divide that by the grams sample, which in this case would be 1 gram in a litre, times our mole ratio. And that's because there is based on this equation here, which is shown here, there are actually...
And this is not balanced.
It's not balanced?
If it was balanced,
Yes?
then we would see that 2 mole ratio.
Yes.
Okay.
Okay, and I'm going to leave that for students to complete that in order to understand how they balance an equation.
Yep. All right, so let's look at an example that Bob has done using this formula here.
So what we've done is we write the initial formula, so percentage of calcium hydroxide is equal A minus B in litres times 74, which is molecular weight, times 100%, times 0.05 molar, which is a concentration of hydrochloric acid, times 50. And then divided by the gram of sample times the 2 mole ratio. So it's 8.06 times 10 to the minus 3 litres, because we're just using, say, calcium hydroxide in solution number 1, and we're just using the mean for this example.
Okay, so let me just go there. So we're just using the mean here for that solution 1.
Yep.
8.06, and there it is there.
Yep.
And there's the conversion to litres.
That's it.
Yep.
Times 74, which is our molecular weight, times 100%, because we're looking for an overall percentage, times 0.05, which is a molarity of hydrochloric acid, times 50, divide by 1 gram, because what we did was we only looked at 1 gram of calcium hydroxide in that solution, times 2, which is our mole ratio. Once you times work out the answer, or for the first part of this equation, it works out to 149.11, divide that by 2, so overall percentage of calcium hydroxide in solution number 1 is 74.55%.
And here it is.
That's it.
Thank you, Bob.
Thank you, Barry.